Hey, can you hear me? Okay. No, I've sent a message, no? I guess they'll come. If I have, get called. How am I supposed to make this small? Mm. I'll start with the first question, okay? Some recent division to division to a question. Add or X or something. Okay. I wait for some 2 minutes, okay? I sent a message in this thing group. Send me the link, okay? Sure. No, I guess I've sent it in WhatsApp. The link. Wait. This No, the problem is okay, okay, okay. Wait. Where should I send it? In the group? I'll send it in the group, okay? Oh, no, I'll send it here. Okay. I'll be starting, okay? This thing, the question, with the first question. Uh, okay, let me just read, okay? Add or XOR, it says. Okay, you're given two non-negative integers, okay? 0, 1, 2, 3, and you can apply two types of operation on A, only on a any number of times and in any order. Okay, we're given two operations uh, where we can add once and the cost of operation is x, and we can XOR is like like 0 0 is 0, 1 1 is 0. If there are like alternative like 0 or 1 or 1 or 0, it's 1. The cost of operation is y. uh, okay. Now we are asked to make A is equal to B if it's possible, output the minimum cost. Otherwise, report it. Like if you cannot do it, if it's impossible, what am I supposed to do? Okay, I guess I'm supposed to report what is it? Report -1. Okay, let's start with the first example. Okay, Eh, is there any good website like something like where I can draw, like Euclid draw something? Okay. Something I don't remember. Do I know any website like where I can draw and explain? Okay, let's see. I found it. See, we are given A is equal to, like, the input says that first is test cases. Okay, we are given seven test cases, seven till seven, and each and every test case contains A, B, X, Y. A, this is A, this is B, this is X and Y. Uh, yeah, the constraints are for AB one lesser than, it's from 1 to 100 inclusive, and for X it is 1 to 10 power 7. No, I found it. It's 1 to 7. Okay, let's start with the first example. Okay, this is 1, 4, 1, 2, and the output is 3. Let us see how is it 3. 1, 4, 1, and 2. This is A. The first one is A. This is B. Now, what is our objective? First of all, it's to make A is equal to B, and we need to print the minimum operations, like, taken to make A is equal to B. Cost of X operation is 1. Cost of Y operation is uh, 2. And what is the X operation like thing? It's adding, just incrementing. A is equal to A plus 1. What is B, that is Y, or Y thing, that is XORing it. So uh, XOR is what, right? Like, 1 1 uh, 0 0 0 1 0 1 0. So this is equal to 0. This is 1. This is 1. But this is 0. This is XOR. This is like basics. Okay, like, if they are opposite, then it is 1. If they are similar, then it is 0. So what is 1 XOR? One XOR can be written as, like, when you go to the binary, it is nothing but one is like the one, and like it's 0 0 0 0 0 0 0, and XOR of this is XOR of one. Like, you have to do XOR with one only. Okay? They specifically mention it's one only. So when we do XOR of odd integers specifically, see, I'll just give an examples of odd numbers. Okay, like, when we do XOR of odd integers, it's gonna decrement. It's gonna be like a decremented. Like, XOR of 1 is what? It's 0. What is XOR of 3? 1, 1. XOR of 3 with 1. That is nothing but 0 0 0 0 0 0 0. Then 1. Then what will it be? It will be 2. See, right? It will be 2, right? Because, where is that? How to go back, back. Okay, because XOR of 2 and 1 is it's 1 and it's 0. So you got it right. What will be the XOR of even numbers with 1? This is like cool. Okay, see, let us take what is it, 4. If we do 4 XOR 1, what will it be? Like 0 0 1. It's going to be 5. It's getting incremented. But when we talk about what is it, uh, the odd numbers, it's getting decremented. You know why, right? It's all on the the one only has one bit. So in the even numbers, the last bit, I mean the least significant bit, which is this, will be always 0 for even numbers. That's why when you do XOR with this thing, oh sorry, my bad. Yeah, that's why when you do XOR with the even numbers, it's gonna get incremented, because 0 and 1 will be 1. So it will be 5. So when you do what is it, this is 5. When you do XOR with an odd number, it's gonna get decremented. So fair enough, right? Now we got to make like we're not gonna have to think of the solution with this thing. Okay, let us see how it works. Okay, then you got it. Did you understand? Using can chat cost driving. No, did you understand till this point? There, Ronak. Okay, you understood. Okay. I just explain you how it works. Okay, this thing. Uh, what is it? How the 1412 is going to be 3? Okay. See, when you think of 1412, the x operation is 1. It cost 1, and y operation it cost 2. When we think of greedy approach, what is the best thing? It's always if you have to find the minimum cost, is it? Minimum cost. It's always good to go with x when we think of what is it? Greedily, but it doesn't always work. But for this test case it works. Okay, 1 to 4 is what? 4 minus 1, it's 3. So you got to add 3 times. If you're adding it 3 times, then it is 3x. What is that? What is the cost of x? That is 1. 3 into 1, 3 into 1, that is nothing but 3 only. So that is 3. Okay, for the first case, the answer is 3. There's no trick over here. Uh, This is not required here, okay? In the first test case, let's go to second one, okay? I think this is something you have to put some brain into it. I think. Let's go. Was it 1512? 1512, okay? This is A, this is B, this is X, this is Y. And the cost of X is 1, cost of Y is no, the 2 1, sorry, 2 1. Okay. Cost of X is 1. This is 2. Okay. Just a second. Okay. I'll try to call this guy. Pratham will come out. Just see. Huh. Is it? Okay. A is 1, B is 5, X is 2, and Y is 1. Okay. Cost of Y operation is 1. So, Ronak, see, now the cost of what is it? Y operation is 1, okay? X operation is 2. So we cannot just add, okay? If we were to add, 4 minus 1 is, sorry, 5 minus 1 is 4. You got a 4 into 2 is 8, okay? If we are doing it just by adding it, okay? Like 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4, 4 plus 1, 5. It's good. It's going to take 4 operations. And 4 operations of X is nothing but 8, okay? But that is not the minimum cost because the output is 6. So how are we supposed to reach 6 now? That is the question. So we got to use the XOR also now. I told you what XOR of odd numbers is. It's decremented. XOR of even numbers is incremented. So from 1 to 5, from 1 to 5, this is very important. We need to count how many odd numbers and how many even numbers. I'll tell you why we need to count how many odd numbers and how many even numbers. From 1 to 5, let's say 1, 2, 3, and 4. 4, okay. These are the numbers from 1 to 5, excluding 5 and including 1, okay. Because we are going to do operations on 1. Uh, 1 is odd, obviously. 3 is odd. And this is even. And this is even. So what I told, XOR on even is going to increment it. XOR on odd numbers is going to decrement it. So I don't need the decrementing option. I don't want to decrement anything over here, okay? Because I'm going to increase it. So this thing, not going to do any XOR because that doesn't make any sense. Like XOR of 3 is 2, which is going to decrement it. It's going to increase the cost anyway. So let's say from 1 to 2, what am I going to do? I'm going to add this x plus 1, that is x operation, which is 2, okay? Then it becomes 2. Now is it 5? Is 2 is equal to 5? Still not reached, okay? From 2, what I'm going to do, I have two operations. I can either do x operation, I can either do y operation. Which is the best operation to do? Like, which is the best operation to do? It's obviously x because it costs less, which is 1. So I'm going to do X operation here. XOR of 2 is nothing but, what is it? Like 1, 0, and 1. That is nothing but, wait, XOR of, sorry, my bad. This is not 2, okay. Uh, I got I got fucked up so very bad. Okay, this XOR of this is 2, okay. When you write in binary, the first one is 2, okay. This is XOR of 2 is nothing but 3, okay, like 1, 1. So it's going to increment it. So now I'll apply Y operation. When I'm in 3, what am I supposed to do? I can choose XOR. Only option which is left to me is this thing. 2 operation. It's going to cost me 2. Now it's is 4. And now I'm at the 4. Is 4 equal to 5? Obviously not. Now I have to do Y operation. Again 1. Now 5. It is 5. It has reached 5. Okay. Is 5 is equal to 5? Obviously. Then what is the cost of the operation? 2, 2, 4, and 1 plus 1, 6. That is how you reach 6. Now, do you understand till here? Oh, hi, bro. Can I get practice questions? Shetty Whitey. Obviously. Hmm. Did you get it till here? Ronak. Let's think about one. Let's try one test cases which is like absolutely impossible to do. Which is that test case? Yeah, 3 and 1. Why 3 is A, 1 is B, X is 1, and Y is 1. Y is 2. No matter how many operations do I do, it's going to be impossible always. So I need to repeat what is it? Print impossible to it. Why is it like mm, 2 and 1? Yeah. See, uh, 3, 1, and what is X and Y? It is 1 and 2. The cost of Y operation is X operation is 1. Cost of Y operation is 2. There. Now I'm talk like explaining the impossible test case, impossible one. Okay. Is it possible that you can convert A to 1? The 1 is the question. If you the first, what is the first what is the option you can do? Increment it. If you keep on incrementing 3, you will never reach 1, but you will reach only infinity. So this thing can never be done. This thing can never be done. Okay, let's talk about this thing. Okay, Is it possible to XOR and reach one? No. Why? Sometimes it's possible, but I'll show you why. What is one and three? XOR, what is it? Binary of three is one one. XOR of one is nothing but it's gonna decrement it, but it will only decrement it to two. Okay, zero and one. What I told, when you do XOR of an odd numbers, it's gonna decrement it by one. Once it has reached two, uh, again you need to decrement it to one to reach one. But the first condition can never be done. Again, you try to do XOR of 2. What is XOR of 2? 1, 0, 0, 1. This thing, what is it? XOR of 1. It's going to again increment it. Now it's going to become 3. Now what is going to happen? Like 3, 2, 2, 3, 3, 2, 3, 2, 3, 2. It's going to be going on an infinite loop. Like because XOR of when even number is going to increment it, XOR of odd numbers is going to decrement it. Uh, I think now you know how to solve it. I believe yeah, just find the number of odd numbers and even numbers and count it and try to greedily reach the operation. I'll be solving the first one. Okay, see. Now let us. I'll be. What is that? Pratham Argoda 3. Okay, now let us. Okay, take the inputs. What's the question name? Add or XOR? Okay, add or XOR dot CPP. CF. Okay, cool. So we gotta handle the test case first. This is the seven. Is it seven? Is it? This is just an example test case. Now let's go and we are given an okay. We are not given an array a b x y c in a b. This is just a simulation problem, but it's kind of tricky, like you have to use like a lot of if else, if else, if else. Let me just handle the, what is that, edge cases. Like, what are the conditions when I'm absolutely, whatever I do, I cannot reach A is equal to B? When is it? Like, this is also not about, possible, okay? 2 to 1. Why can't you reach from A is equal to B, which is A is 2, okay? Is it possible to make 2 to 1 from the first what is that, first task? You can never do it because you are incrementing it, okay? If you are incrementing 2, you're never going to reach 1. You're just going to reach infinity. You're never going to reach B, which is 1, okay? Is it possible to XOR? uh, i I have already obviously told you that XOR of even numbers is gonna just increase it, and XOR of odd numbers is gonna decrease it. If it was 3 and 4, it was valid, if it was 4 and 3, sorry, no, 5 and 4, because XOR of 5 is it's going to decrement it 4 and it's going to reach 4. So let us see the difference, okay? It'll be like if A is greater than, no, A minus B, no, I'll just do, okay, yeah, if A is greater than B and A A minus B A minus B is greater than 1, okay? If it is greater than 1, it's not, obviously not, you can never reach it. Like, if it's like 5 and 3, it's never, you can never reach it. So you gotta straight out, right? C out is equal to minus 1 and then, cool, right? No, what is it now? You know, what? Okay, cool. And there is a valid condition also. Like, let me write if inside this only. If okay, if A is greater than B, We can't decrement. Okay, even number by x. Okay, I'll start by explaining since the first. Okay, because you weren't there. Like the first. See, the question is what, you're given two non-negative integers. Okay, you're given two non-negative integers a and b. You can apply two operations only on a. Okay, it's only on a. They're giving it specifically on a. Any number of times in any order. Any number of times in any order you can do it. What are the two things, two types of operations that you can do? It's either you can increment it, which is going to take x cost. The cost of the operation is x. You can either XOR it. XOR it with what? They've specifically given it XOR with 1. Okay. You know what is XOR, right? Like 0 0 XOR is 1. Sorry, 0. If they're like a similar thing, it's 0. If they're not similar, then it's going to be 1. That is XOR. Then the cost of the operation is Y. Okay. So what is the, let's take an example. This is an odd number. This is 3. Okay. ಕೇಳಿಸ್ಕೊಂಡೆ ಅರ್ಥ ಆಗ್ತದೆಯಲ್ಲ. Okay. This is 3. Okay. 1 1. What is the XOR of 3 now? What is it going to be? 0 0. This doesn't matter. Okay, these are like more significant bits which are always 0 0 0 0 0 0 0. So, okay, let us talk about this thing. 1 and 1, what is it going to be? It's going to be 0. And is it going to affect anything? The 1, is it going to affect any other digits here? No, it's going to be same as it is. Something. No, what is going to, what is happening here? What, it's getting decremented. The odd numbers are going to be always decrement. Anything, you can take anything, 3 5 7, anything. Just do XOR with 1. Simple reason being that 1 is the 1 has the set. Okay, set at the least significant bit, and even the odd numbers is that least significant bit are set. If they're a set, then it's going to be 0. If the last least significant bit is going to be turning into 0, it's going to get decremented. Let us talk about this thing, 4. Okay, 4 is an even number. What is that? How do you tell then number is even or odd? Just by looking at the least significant bit, you can just look and you can tell. Okay, what is the XOR of 4? It's going to be 1 0 1. Nothing is going to change here. Okay, it's going to be 5. So what is the trick that you have seen? It's getting incremented. ಗೊತ್ತಾಯ್ತಾ? Huh? 4 is getting incremented. 2 is getting decremented. 1 0. Okay, now see, where is it getting decremented? 1 1 dissimilar thing, it's getting incremented. No, 3. Did you get it? Like 2 is getting incremented, all the even numbers are going to get incremented at the end of the day, and all the odd numbers are getting decremented at the end of the day. No, decrementa. How is it getting decremented, bro? 2 is not getting decremented in any sort of, like, how is it getting decremented? Like, wait, okay, I'll just create a Zoom call and I'll ask you. Wait, it's better that I can't. What is that Zoom meeting? What is it? Google meeting? New meeting. Start an instant meeting. Okay. Come. Okay. ಗೊತ್ತಾಯ್ತಾ? Just join here. Okay. If you have any doubt, you can just shout there. Okay. Google Meet. I have created the Google Meet. Just I'll keep it open. Okay. It's gonna be open for everyone. Open. If you have any doubt, okay, you can speak up there. Okay. 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 So, okay. For Pratham, okay, if Pratham wasn't available at the start, okay. So I'm going to teach him the second operation, okay. Second, this thing. He'll understand it now. Like, what's the trick over here, okay. Now, 1 5. What is that? 2, right? It's 2. 1, okay. 1, 5, 1, 2, 1, okay. A is 1, B is 5, cost of X operation is 2, cost of Y operation is 1. Now, what is the simplest solution you can get? Okay, not you don't have to think about anything minimum. What is the simplest you can do? It's either you can increment it. Let's just increment it. Okay, 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4. How many operations? 4 operations. 4 operations means 4 times of 2. That is nothing but 8. But is it actually minimum? No, it's not minimum. You can just look at the test case. Okay, it's not minimum. 6 is the minimum. Why is it 6? How is it possible that we can achieve 6? That's the question. Okay, so the trick over here is that then you have to check how many odd numbers and how many even numbers are there. Okay, uh, okay, one including one and not including five, because once it has reached five, we are not going to make any operations on it. So we'll start with the things which we are going to make any operation, any sorts of operation on it. Okay, one, three, or odd numbers, two, four, or even numbers. We can see the cost of y operation is less. That means XOR operation is less. So we got to apply XOR on things, okay, which can be applied. So when you look at this, one, 1 and 3. Can you apply XOR in it? No, you cannot apply because it's going to decrement it. Okay, we don't want to decrement it. We're gonna increment it. So only on 2 and 4 you can apply XOR. So what will be the cost? 1 and 1. Okay. See, let us first go from 1. Okay, we're going to add. Okay, we cannot do XOR on 1 because if we do XOR in odd number, it's going to decrement. 1 XOR is 0, so we're not going to do it. So we'll just add. Okay, it's going to take, what is the cost? It's going to be 2, which is X operation. We are adding it, incrementing it. Okay, incrementing it. A is equal to A plus 1. Now once it has reached 2, we can do both of this operation, any of this operation. What are we going to choose? We got to choose Y operation because we want to decrement minimum cost. You got to find the minimum cost. So once it has reached 3, XOR of 2 is 3. Once it has reached 3, we can only do this thing. So we'll do this thing. Once it has reached 4, we can do two operations. Which are we going to choose? One. Once it has reached 5, 5 is equal to 5. So we got that A is equal to B. So we got to stop it. Now we got to count what is the cost. What's the cost? Like 2 plus 2, 4, 1 plus 1, 2. It is equal to 6. Okay. Hey, big fan, bro. Okay. So cool. Okay. Now we understand. Pratham, Budaitala. Pratham. I think you got it now. Only on the even numbers, we can do XOR operations. So now I'll just write it. Okay. I've handled the edge cases and all. CO, it's gonna be only Y over here. Okay. These are the edge cases. Okay. I don't think there are any other edge cases. There are. We'll see. Now the question is, how are we going to do it? Okay. I just have to write a while loop, I believe. I've taken A, B, X, Y. Okay. If X is lesser, so we don't have to do any XOR operation on which we can just return it. If X is lesser than Y, we only have to return B minus A, I believe. Yeah. Which is 4 minus 1, which is 3. Okay. The first question is that. The first test case is that. Okay. That itself. Now the tricky thing is when X is greater than Y. That is else condition. We're going to handle it in else. How are we going to do? Count the number of even, count the number of odd. For even numbers, we can do XOR operation. So we can do it. So I'll just write int count even. Int count even is equal to 0. Int count odd, that is equal to 0. Now is there any trick to do it like 4 4 1 to 4, just like O of 1 operation? We can do it in O of n, also like counting that. We will do it in O of n only, okay? Just for the sake of simplicity. Uh, while. Okay. Okay, let's just count, okay? While A is not equal to B, A is not equal to B, If a percent 2 is equal to 0, then count even plus plus, else count odd plus plus. At the end of the day, we got to increment it. Okay. Okay. Now we know there are certain number of even numbers, certain number of odd numbers. Okay. What am I supposed to do? XOR on even numbers. XOR on even numbers. So let us call cost. Okay. Min cost, that is equal to 0. Uh, or count even the number of even numbers that I have to multiply it with y, that is equal to min cost plus or is equal to min cost plus or is equal to count or into x, I believe. Yeah, I think that's it, I believe. Let us now test. Okay, now I have the tool to test it also. See, copy, create a problem, input. Hopefully it will go. What is this? Big numbers. I don't think so I have handled big numbers. We'll see. I could use long anytime I want. I just want to just don't want to use it. Let's see if it's runs. Okay, what is the issue? Okay. Okay, I failed it. Where did I fail it? Okay, I'm returning minus. Okay, why am I writing 2 over here? Which is the test case 1, 2, 3. Okay, last third case test case. Okay, 2, 1, 1, 2. 2, 1, 1, and 2. Okay, 2, 2, 1, and 2. Okay, let's see. A is 2, B is 1, 1, 2. A is 2, B is 1. How am I supposed to do? No, I can't do it. So if it's A is greater than this thing. Okay, it has to be even, no? And A percent 2 should not be equal to 0. Now I guess it should work. Yeah, still failed. A percent 2. What is that? What is A? A percent 2. It should work. No? A percent 2 uh, should work, I believe. Mm, A is what? A is 2. It should not be divisible. Or is it? Okay, yeah, it should be divisible. Okay. Okay. Or I believe. No. No, 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 no. Uh, what am I supposed to do with this? A minus B is greater than 1 and A percent 2, I believe. Or just screwed it up, I believe. Wait. Or no, or doesn't work. Oh, yeah, or works, I believe. Yeah, it does work. Okay, it passed the test cases. These test cases are passing. Let us see if it works. Okay, I believe it should work. Download Codeforces, Codeforces rating 900 or divisor. No, was it 9? Where was the file stored? Okay, it was in 800. My bad. Codeforces, code rating 800. Let us see. Hopefully it works. I think it'll work. I don't know if I haven't handled. Okay, it's submitted successfully. Running on test 2. Oh, it's on wrong on test 2. What did I mess it up? Uh, the fourth word differs. 17651111184. How am I supposed to do it? Screw it up. Fourth one, huh? 1776. Fourth word differs. What the hell? What in the world did I do? Okay, let us go through it again. Okay, let us see what am I doing. Which test case was it? Compare, where was it? Submission, standings, status. No, this is not me. What did I mess up to? Let's just go through the code only. What are the impossible ones? A, B, X, Y, A is greater than B. If A is greater than B, A minus B is greater than 1, obviously I cannot do it. Okay, I think I messed it over here. Did I mess it over here? No, it's totally fine, I believe. And if it's not, I'll be returning Y. Okay, cool over here. So it's X is less than Y. If X is less than Y, P minus A. Otherwise, okay. Well, let's see, it should be cool. 1, 2, 3, 4. Why is it congruent? Which test case is it? Okay. Participants output. Oh, 0. Why am I getting 0? Okay, 0. 9, 9, 7, 7. Okay. Okay, here it's going wrong. Fourth test case. What is the 4? 1, 2, 3, 4. Okay, this thing. Let us see what did I mess it up here. 8. Okay, gotta do from 1 to 4. 1 to 4. Uh, okay, this is less than, x is obviously less than x is less than y. B minus a. Okay, I got to multiply it, right? My bad. Multiply it with x. Silly mistake. Okay, now it's gonna run, I believe. What did I fail it now? Oh, it's going out of bounds. How do I handle this thing also, I believe? Okay, what's wrong over here? What did I mess up? 3613, 3613, minus 1. Received output. Okay, my bad. Was it 16? No, 1617651113118 4. Okay, let's just do some this thing also. What is that? Yeah, long. And I don't think so. That will be an error, I believe. Okay, how am I supposed to go back? Okay, now let's submit it now. or it's accepted. Finally, solve the first problem. Who are there? It's finally first problem is solved. Hello, anyone there? Nobody there. Oh. Okay. Godaitena. Pratham. Got it. Thanks. Okay. Let's start with some easier problem. Okay. This was some division 2 one thing. Division 2 thing. Okay. This is like a division 2. Uh, let's start. Actually, last contest. Okay. I attended one last contest. Okay. I was able to solve 3 questions over here. Which was it? This thing. We'll start with the first question. Okay, I'll just explain. Okay, it's kind of tricky. Okay, when you look at this question, but they are not actually tricky when you solve it. Okay, they initially given 0 to n minus 1. Okay, 0 to n minus that are written on the blackboard. In one round, Alice can choose an integer a on the blackboard and erase it. Okay, she can erase it. And Bob can choose an integer b on the blackboard such that a plus b congruent of 3 mod of 4 and erase it. Okay, getting the question. See, once I start explaining the test cases, okay, this thing you will easily get it. Okay, okay. The round takes place in succession. until a player is unable to make a move. The first player who is unable to make a move loses. Okay. Determine who wins the optimal play. So the answer is going to be is if allies cannot make the move, allies is going to lose it and Bob is going to win it. If Bob cannot make the move, next move, Bob is going to lose it and allies is going to win it. Okay. So what is the question? It looks very tricky. Okay, the answer is very silly. A plus B congruent something. I don't know how to spell it, but A plus B. When you mod it with 4, then the remainder should be 3. That's it. It's very simple. Okay. See, let's take an example. Okay. It's very simple, but it looks very tricky. This was the first question and the easiest question. Okay, A is the easiest one. That I solved it at the end. Okay, I thought it was very tricky, and I was like, I couldn't even understand at the start. Then I was like, okay, let me give it a try. Then I could solve it. Okay. What are the first line? What does first line contains? One is less than or equal to t, which is the test case. Okay, test case. The number of test cases, like which is five test cases. They are given five, 2, 4, 5, 700. And what is n? That is a number. Okay, number of integers that are written on the blackboard. If suppose if there are four. Okay, let's go with four. Four. How many numbers are going to be written? Written on the blackboard. That is 0, 1, 2, 3. Why not 4? Because they have like they told it in the they have explained it in the rule that it is going to only have 0 to n minus 1. So let's go with 4. Okay, which is a test 4. Okay, 0, 1, 2. This is let's say it's a whiteboard now. Okay, it's not blackboard. It's a whiteboard because I'm using white thing. Okay, these are the numbers which are written. Okay, so in one round, what is going to happen? Alex is going to start. Okay, they have told it here. The ally chooses an integer a. What can an ally choose? Allies choose here anything. It could be 0, 1, 2, 3. Okay, let's say allies chooses 0. She chooses 0. Now allies can choose the what is it? The most important thing is that allies can choose anything. She can choose anything. Say 0, 1, 2, 3, anything which is written on the blackboard. Okay, anything. It could be anything. 0, 1, 2, 3. But Bob has a rule. Okay, Bob has a rule. He can only choose in such a way that whatever allies has chosen, and he has got to add it with the remaining number. This is erased. Okay, once allies has chosen it, it's erased. Whatever the numbers which are left here, like 1, 2, 3, Bob has got to add it with uh, a, which is 0, which Eliza has chosen, and mod of 4. Okay, mod of 4. Okay, should be equal to 3. Only then Bob can choose it. So it's given here. A plus B congruent of 3 mod 4. So Bob has a rule. Alice doesn't have a rule. So it's like Alice has a lot of ways to win it. Okay. See, let's see who's going to win this first game. Okay. Like N is 4. Okay. So let's say Alice has chosen 0. Bob has chosen 3. 0 plus 3 is 3. 3 mod of 4 is nothing but 3. So both are cancelled. Now, let's say Alice chooses 2. Bob can choose 1. Still going to work out. Now, 2 plus 1 is 3. 3 mod of 4 is nothing but 3. So, it still works out for Bob. Okay. Now, Alice has got to choose a number. The main thing is that Alice cannot choose any number. Why? Because everything is arranged. Now who is going to win it? Bob. See, when it is 4, okay, Bob is going to win it. So how do you tell if given an integers who is going to win it? It's very simple, okay. It's very, very simple. If you give it a thought, you'll get it. Okay. The thing is that anything like multiple of 4, like which is divisible by 4, like anything it could be 12, 16, or anything till infinity. If it is divisible by 4, then it's going to be Bob always. No matter what, it's going to be Bob. Bob and Bob. See, 4. 4 is divisible by 4. 0. That's why it's going to be Bob. 100. When you think of 100, 100 is also divisible by 4. It's going to be Bob. But if it's not divisible by 4, it's going to be Alice. Why? Why so? Let us see. Okay. 1, 2, 3, 4, 5, and let's say 6. Okay. 6, the given number is 7. Okay. And 0 also. My bad. 0, 1, 2, 3, 4, 5, 6. Now tell me who's going to win it. What did I tell? 7 mod 4. 7 mod 4 is nothing but it's not divisible by 4. Obviously, 7 is not divisible by 4 into 2 is 8. 4 into 1 is 4. 4 into something is nothing. Is not equal to 4, 7. Okay. Let's say Alice chooses 0. Bob will choose 3 now. This both are erased now. Now, Alice will choose 2. Bob will smartly choose 2. Till here he was smart enough to get it. Now this 4 numbers are deleted. Now let's say Alice chooses 4. What can Bob choose now? He can choose 5 or 6. 4 plus 5 is what? 9. 9 mod of 12 is 1. So he cannot choose 5. 4 plus 6 is what? 10. 10 mod of 4 is 2. Still not equal to 3. Now who is going to win it? Even if there are 5 and 6, Bob cannot choose anything because even if he chooses anything and he adds it, okay, it's still not going to get 3. So it's always going to be this guy who's going to win it. Let's just code it up, okay? Let's see if it works or not. You can never be sure until it runs everything, okay? What's the question? Blackboard game. What did it tell? If it's divisible by 4, it's going to be Bob. If it's not, straight out allies. Blackboard, CPP, CF. Okay, let's see. T. Okay, this is how you take the inputs. Okay, like int t, c int t. The test cases like declaring the integer, assigning the integer. Now it's going to store 5. Let's say it's going to store 5. Then I got to loop till every other test case. Now let us say long and let us say int only. It's going to be only like constraint is only given till 1 to 100. So to store 1 to 100, it's yeah, integer itself is enough. And okay, my bad. Okay, what did I tell? If n percent 4 is equal to 0, if mod of 4 is equal to 0 means Bob is going to win it. Bob, 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 my bad. Does anyone have doubt? We are here, brother. Does anyone have doubt to this regarding this problem? If we still have any doubt, you can no, raise your hand. What is the doubt? Else it's going to be arise every time regarding this problem. Like if anything it could be. Okay, I don't need to test it also. I think just go straight out, write it blackboard. Oh, it's accepted. Oh, it was accepted. Oh, it's accepted. So it works. Logic works. Does anyone have doubt here? Is anyone online? Does anyone have doubt here? Got it, no? So it's very simple, but it's kind of tricky, when you look at the question like A plus B congruent of something mod of 4 something. It's kind of tricky when try to break it up, no? Like taking the test cases and all. It's very simple. Nothing hard in it. Okay, let's try solving some 800 rated problem. Okay, um, let's go to contest division 4, division 4. Okay, okay, we'll go to division 3 one. Square here. Okay, let's see this thing. Okay. Okay, let's see this question. One can notice the following remarkable mathematical fact. The number 2205 can be represented what is this, bro? 20 plus 25 square. Is it so? 20 square is 20 plus 25 square. Okay. 20, how is it possible? 20 20 square, 20 plus 25 of whole square. That is nothing but 20 square plus 25 square plus. It's just very mathematical thing. I don't want to do it. Let's just do it. Okay. 2 into 20 into 25. Okay. Let's see if it's actually 400 plus 625 plus. Let's just bring out calculator. Mathematical questions. I hate doing it. Okay. Was it 20, 400 plus 625 plus 20 into 25 is 500. 500 into 2 is 1000. 1000, 2025 only, no? Okay, 2025. Actually, it works. Okay, okay. That's a mathematical fact. Okay, given an year represented as string consist consisting of exactly four characters. No, pa. You didn't understand, Pratham. What was your error? You can join the Google Meet now. Wait, I'll just create and start an instant meeting. Just forward the link here. Open. Okay. Cool. I think. Okay. Let's see. Join it. ಪ್ರಥಮ ಏನಾದ್ರು ಇದ್ರೆ ಕೇಳ ಅಲ್ಲಿ doubt. Till then, we'll be solving this thing. Represented by a string consisting of exactly. Let's put it a cooler cost. Thus, leading zeros are allowed in. Okay. Thus, leading zeros are allowed in the year representation. For example, 0001, 0185, 1375. 1375, a valid year representation. You need to express it in the form of a plus b square, where a and b are non-negative, obviously. And or is it impossible? What is this, bro? It's kind of tricky. Okay, we're given a string. Okay, okay, okay. We got to print a and b, something similar to this. How is it possible? Hey, what is this? Is it even 800 rated? Seriously? So, let's see. 0001, 1001 cannot be. 1000 also cannot be represented. 4900 can be done. A plus b is greater than 0. A plus b, okay, if it exists. Okay. A 0, b is 1. Okay, cool. How am I supposed to break it? Not even understanding this thing. We'll go to some other problem. What is this square mathematical thing? Is there any division 4 here? Let's see. Repeat a P. Repeat a P resists in a string for where Asian name of each country consists of phrasing. First letter of each string is concatenated by to form countries. Given the country's Asian name, please output the modern name. United States of America. Okay, what is it? First letter of. It's very easy thing. Let's do. Let's do some this thing. Division 3. It isn't. Okay, we'll say this thing. Kind of interesting. We can call an array A consisting of k positive numbers. Palindromic if A1, 2, 3, k is equal to A k. Okay, obviously that is palindrome. For example, the area arrays 1 to 1 and 5 1. Okay, this is also. Fair enough. Palindromic, while the arrays 1 to 3 can call an array A consisting of k positive integers. Palindromic if A1, A2 till AK. For example, the arrays 1, 2, 1, 5, double 1, 5 are palindromic. How so? Okay, okay. We call a number k an ideal generator if any integer n is greater than k can be represented as the sum of elements of a palindromic array of length exactly k. Each element of the array must be greater than 0. For example, the number 1 is an ideal generator because any natural number 1 can be generated using the array 1. However, the number 2 is not an ideal generator. There is no palindromic. Okay. Can call an array A consisting of k. But I think I'll just stop it here. Just another 5 more minutes. We'll see if I get the solution for this thing. If I don't, I'll just stop it here. A consisting of k positive integers. Okay. 3. That is 3, I believe. K positive integers. For example, palindromic. Hmm. We can call k an ideal generator if n is greater than or equal to k. 3. Okay. And k and can be represented as a sum of the elements of a palindromic length exact k. Is there any explanation also? There's no explanation. Question only each of this is k, k. So I'll be stopping here. We'll be doing it tomorrow also. Right now I'm very tired. We'll just go to lead code and I'll do. I just don't want to do code versus some lot of mathematics here. Yeah, just stop. Thanks for